Hi, my name is April Locklear. For my final project, I chose to analyze personal debt using quantitative methods learned in this course. This presentation focuses on how debt grows over time due to compound interest and how mathematical modeling can help explain the true cost of borrowing. Debt is a common real life issue that affects individuals and families, and understanding the math behind it can help people make more informed financial decisions. Throughout this presentation, I will explain the assumptions used, the mathematical concepts applied, and the conclusions drawn from the data. I'm looking at how debt grows over time and how math helps make us make smarter choices. Financial choices. Many people take on credit card or loan debt without fully understanding how interest works or how long repayment can actually take. My goal is to analyze a realistic debt scenario and see what happens when only minimum payments are made versus using a more intentional payoff strategy. By the end, I want to show why it's important to look at numbers instead of just the monthly repayment and how this applies to real life budgeting and planning. The purpose of this project is to explore how debt behaves over time when interest is applied and only minimum payments are made. I selected this topic because debt is something many people experience, yet the long-term impact of interest is often underestimated. My goal was to answer the question, how does high interest debt grow or shrink over time, and what does that mean for borrowers? By applying mathematical concepts such as percentages, compound interest, and exponential growth, I was able to model a realistic debt scenario and analyze the results. Several mathematical concepts from this course are used in this project. Percentages are applied to calculate interest rates, while compound interest explains how interest builds on previous balances. Exponential growth is used to describe how debt can increase rapidly over time when interest compounds monthly. Tables and graphs help organize and visualize the data, making trends easier to identify. These concepts are essential for understanding the time value of money and how borrowing decisions impact long-term financial outcomes. To understand debt, I first used several math concepts, percentage growth, because interest increases the balance by a percentage each month. The second is exponential growth, which happens when interest gets added repeatedly and the new total keeps growing on top of itself. I also use formulas for monthly interest and tables to track totals over time. These concepts are important because they show that debt doesn't grow in a straight line. It grows faster the longer you carry it. To keep this analysis realistic, I modeled a common credit card debt scenario. The initial debt balance is $10,000, with an annual interest rate of 18%, which is typical for many credit cards. The borrower makes a minimum monthly payment of $200. The analysis covers a 10-year period. These assumptions allow us to see how debt changes over time under conditions that many people actually face. An 18% annual interest rate means the lender charged 1.5% each month. That may seem small, but it adds up quickly. Every month, interest is calculated on the remaining balance, and then that interest is added to what you owe. If your payment is small, a big portion goes towards interest instead of reducing the principal. This is where people get stuck. They keep paying, but their balance barely moves because interest keeps rebuilding. As payments are made each month, the debt balance decreases very slowly. A large portion of each payment goes towards interest rather than reducing the principal balance. This is especially true in the early years of repayment. Even though the borrower is consistently making payments, the balance does not significantly decline because interest continues to accumulate. This demonstrates how compound interest works against borrowers. After analyzing the data over 10 years, the results are striking. Although the original debt was $10,000, the total amount paid over 10 years is approximately $24,000. This means about $14,000 is paid in interest alone. In other words, the borrower pays more in interest than the original amount borrowed. This highlights how expensive high interest debt can become over time, and how lenders profit when balances stay unpaid for long periods. This table helps make those hidden costs visible. This visual representation helps illustrate the data more clearly. The line graph shows the remaining balance over time, while the bar chart compares how much of the total payments go towards principal versus interest. The graphs make it easier to see that the balance decreases slowly and that interest dominates the repayment process, especially in the early years. Visualizing the data helps make the impact of compound interest more understandable. An alternative strategy involves increasing the monthly payment rather than paying only the minimum. Even a modest increase in monthly payments can significantly reduce the total interest paid and shorten the repayment period. This comparison demonstrates how small changes in financial behavior can produce large long-term benefits. Using math to compare strategies helps borrowers see which option is more financially effective. Several key findings emerge from this analysis. High interest rates cause debt to behave exponentially rather than linearly. Minimum payments extend the repayment period and dramatically increase the total cost of debt. Taking action earlier and paying more than the minimum can save thousands of dollars in interest. These findings emphasize the importance of understanding interest rates and repayment strategies. The analysis has strong real-life relevance because credit card debt is common in many households. Understanding how debt grows can help individuals reduce financial stress and make better budgeting decisions. Mathematical analysis provides clarity that emotional decision-making often lacks. By understanding the numbers, people can make informed choices that improve their financial stability. In conclusion, this project demonstrates how debt grows exponentially while interest compounds over time. Mathematical analysis reveals the true cost of borrowing and shows why minimum payments are often ineffective. Applying quantitative reasoning to personal finance allows individuals to make smarter and more responsible financial decisions. This project illustrates how math learned in the classroom can directly apply to everyday life. Through this project, I gained a deeper understanding of how debt grows over time and how powerful compound interest can be. Before completing this analysis, I knew that interest increased debt, but seeing the data and graphs made the impact much more clear. This project helped me connect mathematical concepts from this course to real-life financial responsibility. Going forward, this analysis will influence how I approach borrowing and repayment decisions, reinforcing the importance of minimizing high interest debt.